There is no single now in the universe. Why? Strap on your goggles. It's time for CurioLab. There is no single universal simultaneity because of how time is structured. In physics, time is treated as a dimension, just like space. Think of time as a direction in which events are ordered. You move through it constantly. Every event in the universe needs two things: where it happens and when it happens. So in physics, objects don't just exist somewhere. They exist somewhere at a specific moment. If nothing can be compared to anything else, like a before or an after, then nothing has changed. Time is what lets the universe have states. Without time, there are no states. Only a single, unchanging one. Because time is a dimension, it works like a coordinate. Just like space tells you where something is, time tells you when it is. Only with place and time can an event be fully described. This works in everyday life. But the universe has its own tricks. Time can change. Not how it feels, but how it actually elapses. To measure time, you must compare events. An event where something starts, an event where something ends. Different observers, moving differently from each other, do not agree on how much time separates those events. Between the same two events, fewer internal processes occur in the moving system than in the stationary one. At sufficiently high speed, a moving system accumulates less elapsed time than a stationary one. This difference is called time dilation. Time dilation is a consequence of special relativity, which describes how measurements of space and time depend on relative motion between observers. Each observer carries their own measure of time, called proper time. To fully understand why motion changes time, we need one more idea: space and time are not separate. In modern physics, space and time form a single structure, called spacetime. It's a single, dynamic, four-dimensional continuum. It means that an event is not just something that happens somewhere, and not just something that happens at some moment. It happens somewhere in spacetime. In spacetime, motion affects not only where an object is, but also how it progresses through time. In simple words, when you change how you move through space, you also change how you move through time. Different motions correspond to different paths through spacetime. As a result, different observers can measure different amounts of elapsed time, even between the same two events. The time dilation described earlier exists because space and time are described within a single structure. So far, we've seen how motion at sufficiently high speed changes how objects move through spacetime. This is special relativity. But motion does not change spacetime itself. So what does? General relativity introduces another central concept: gravity. Next episode, the gentle puller awaits.